Okay, hi, I'm Željko. Great to be here today, a lot of great presentations. Once again, thanks to Andre and Thea for selecting my presentation for DevOps. And today I'll talk about how to develop Android apps like Navy Seals. It's a great title, don't you think? I thought that it would sound a little bit more dramatic, like war music playing in the background and Navy Seals invading the hotel from the rooftop, but this all will happen next year. Actually, today I will talk about how we organized our Android development process at Infinum due to all the changes which happened to Android OS in the last few years. So for short introduction, I'm an Android developer at Infinum. Infinum is a software agency from Croatia, and we have offices in Slovenia and USA. And I've been involved with Android development for a few years now, and I've seen everything. So from bad things, worse things, catastrophic things to good things. And that's basically how I want to start my development story today with you. So if you go a few years back in time, like 3 or 4 years ago, developing even the simplest Android application was a really hard and tough process, because basically we didn't have anything. If we take a comparison with web development, 3 or 4 years ago it was basically a standard that you use CI and automatic tests and crash reports and analytics in web development, and we didn't have the tools to do this on the mobile. So basically we just had Eclipse with ADT plugin, which was buggy, and that was it. One more thing is that we didn't use any coding or architecture pattern. So all of our Java classes had like a few thousand lines of code, and it was really hard to perform some debugging and maintenance. And we also didn't use any static code checks, which heavily influenced our quality. And in most cases, we had problems, like we had some bug, we fixed it, and 2 or 3 months later, it happened once again. And you probably all think that, yeah, we should use regression testing, but at that time, we didn't have the necessary tools, and the tools that were at that time available for Java were simply not good enough to use on Android platform. And things quickly start to heat up as Infinum was expanding. Our Android team quickly grew from 4 to 5 developers to 10, and a new world of problems arose because we started to work as a teams in one project. And we quickly got a lot of problems with Git conflicts. Every developer had its own code style, so like they used a different logic to solve business problems. They have different patterns for method naming and variable naming. And also at that time we were doing a lot of long-term projects, and developing them quickly became hell, like complete hell, because even if you wanted to switch between the environments, this was done with few lines of code in terminal, and then you had to wait like 5 to 10 minutes that your application was built once again. And just one day we sat in our office and we said, okay, this is not fun anymore, this is going nowhere, we need to do something, because we'll probably kill ourselves if we have to do some more resolving Git conflicts and so on. And so we looked at the other fields of development, especially web development, and we saw that they are using CI, tests, analytics, and we said, okay, this is great, this is battle tested on some other platform, and let's say that our goal in the next few years is to completely integrate continuous integration in our development process. And then we started with little steps to reach this goal. The first thing is that we introduced Git flow to our development process, So basically, you probably all know what git flow is. If you don't know, it's a design pattern for organizing your branches. So basically, you have one stable branch, which is called master, and then you have unstable branch, which is called develop, and then you switch between them, perform some merging, checkout, and so on. And with Vim, we use one master branch, which always holds our production code, and releases are tagged with version numbers. So if some crash occurs in production, we can easily check out all the versions of our applications. Main development is always done on the development branch, and from that branch we check out feature branches for every feature, enhancement, bug, and so on. A lot of advantages. Git flow has a lot of advantages. I would point out just two of them. The first thing is that it's easy to keep developing the next version of your application while maintaining the current version, and it's easy to review code by pull requests. I don't know if you are using pull requests in your companies, but if you are not, please use them because they are a great tool for knowledge fluctuation, especially if you team up more experienced developers with the junior developers. They will quickly became better developers, and at that time a lot has changed. A lot has changed with Android, and we got new tools. The first tool was Android Studio, which is an IDE designed especially for Android development, and it's based on IntelliJ. And we also finally got great Android emulator. So if you use default emulator, it's so painfully slow that you cannot perform any normal development. But if you use Genymotion, it's almost as good if you develop on real device. And then we said, okay, let's start to automate the things. And the first thing was that we analyzed our current development process, and we saw that we have a bottleneck when switching between the environments. And we said, okay, something has to be done here. And at that time, Gradle was announced, and Google soon said that Gradle will replace Apache Ant as a main build system for Android. If you don't know, Gradle is an open source build automation system, which is based upon Apache Ant and Apache Maven. If you don't know, we can say that Apache Ant is something like Make in terminal, and Maven is some kind of external repository which holds all the libraries which you include into your application. And the great thing is that Gradle uses Groovy-based domain-specific language, which is great for Java developers because it's actually built on the top of the Java, and it has a really nice syntax. This is one example of Gradle configuration file for Android application, and as you can see, I have defined some build types and product flavors, and those are basically the two core concepts of Gradle for Android. So basically, with build types and product flavors, you divide your application into different groups. So for build types, we usually have debug, staging, and release type, and product flavors are optional. They perform some more complicated division of your project, like if you want to switch between test and production API server, if some Java class has one implementation in free version of your application, or some other implementation in paid version. And by combining build types and product flavors, you get build variants. And this is the core concept of Gradle for Android. Each type has its own setup. So you can see that in an example, release build type is always obfuscated with ProGuard, so the final APK file is smaller. Logs are never visible. In most cases, we have enabled crash reporting, static code analysis, while debug type is never obfuscated, logs are always visible. So basically, debug is always used for development purposes, staging is sent to our clients for testing purposes, and release is the build type which goes to Google Play. For product flavors, as I said, they are optional, and they vary from one application to another, and in most cases we use them to switch between API endpoints for different build types. And by combining flavor with build type, you get something like this. This is a production debug build variant, which targets the production REST API endpoint, but has everything what we defined in debug build type. So logs are always visible, it's not obfuscated, and if you have some crash or some bug with this variant, you can basically pinpoint the exact location of your bug in like a matter of seconds. The great thing is also that build types and product flavors can contain build-specific resources and Java classes, and this means that we can use different app names, resources, icons, logging mechanisms for each build type, and then we can have something like this. So now I have like one application which is defined into 2 build types. Each build type has a different app name and app icon, and I can install both of these types on one smartphone. So yeah, that's really, really great. And then we said, okay, let's dive into testing. Now we are finally able to write some tests, and we soon bumped into a wall because our code was not easily testable. The main problem was that whenever you did some UI change to your code, like remove some button or change its behavior, you had to completely rewrite all of your tests because they would break down. And it was a really hard process, so yeah, it was really pretty stupid. And once again, we look at the other platforms, and we quickly saw that we need to change our code architecture. And that's when we started to use MVP. MVP is basically a derivative from MVC, which is really famous in web development. The main difference is that models and Vue never communicate directly. Each of these components has its own interface and implementation, and we always use some additional model classes for dependency injection, and here we use Dagger, which is really great tool. Now if we look at each component, Vue is basically a stupid Java class which only handles the UI events. So basically it propagates all the events to the presenter, and it exposes the methods for manipulating the view to the presenter. It doesn't hold any business logic, it's just a stupid Java class which only holds user interaction. Presenter is a middleman between the view and the model, and it makes them independent. It also holds a reference to the view and the model, which is injected with Dagger. And finally we have model, which is a gateway towards business logic. It contains methods for data retrieval, and in most cases we add one more layer. We call it interactor, and on this layer we do some long-running tasks like networking or fetching data from databases. And the great thing about MVP is that it's finally testable. Now we started to write tests, and once again it was a method of success and fails, because we wanted to write tests, but we wanted it to be the simplest as possible. So if I have to write tests for 30 minutes, it's not okay for me. And the first approach was that we started using unit testing for presenter, and we mocked the view and mocked the model. This is okay, but you had to write a lot of boilerplate code, and it's simply not natural, because if you mock everything, then what's the point of the tests? So then we have second approach. We started to use RoboElectric, which is an Android library which mocks Android virtual machine, and we mocked only the model, so we reduced the boilerplate code, but once again it was not as natural as it should be. And the third approach, the final approach, was that we used RoboElectric so that we can perform testing on our computers. And we used mock web server, which is basically a server which is started on your local host, and it plays as an interactor between your application and some remote server which you are targeting with your REST API endpoints, and it returns some fake responses to your application. So this is the preferred concept, and the great thing is that now you don't have to mock anything, you just have to provide some fake responses which you copy from the original responses from your test or production server. And the great thing is that basically now you can, if the server is not responding, if API calls are not implemented on their side, on the customer side, you can mock it and your application will still work. So at that time, our development process looked a little bit like this. So we have implementation, you implement some feature, then you write tests for it. If everything is going okay, you go into release. At some stage later, you're now in post-release stage. We define new features, enhancements, and then we once again start with implementation. And that was really good, but and now we were finally able to start working with continuous integration. And if you look into it, continuous integration is really, really important because, let's face it, we as the developers are very lazy. And if we don't have some build server which will automatically start our tests, those tests will never be started. Because if I start some tests and I break some code, as Daniel said before, I will take the blame of it. I will probably get some spanking from my boss. I will have to fix it. So we need a mechanism which will automatically start all the tests when something is committed, or to be more precise, when something is changed with our code. And we need to point out to the team when tests are failing. So we need to use some notifications or emails or stuff like that. We decided to use Jenkins, which is an open source CI server. It's written in Java and it runs on Windows, Linux and Mac. And if I had to do all over again, I would probably kill myself before I use Jenkins once again. And this is the CI setup which we currently use in our process. So basically when you commit some change to Git, it clones the latest changes to Jenkins. It automatically builds your application, starts the tests, and the results are sent to HipChat server or email, and also test results are archived. It's a really great picture. It was written by hand. Yeah, so good. So yeah, this is I just said this. The main problem with Jenkins was the configuration, and to be completely honest, I still don't know how I managed to do it. I still don't know how the Jenkins works, because we had a lot of security problems, because our clients will probably kill us if we send the source code to some remote server. So we had to build it all internally in our company's network. So currently we have a Ubuntu machine which holds Jenkins server. We filter all incoming network traffic and we use it specifically only for Jenkins, and it's like located 10 levels below the surface, logged with 54 keys and so on. Also, after we started to use CI, we wanted to do some fine-tuning of our code, and we soon found out that now there exists a lot of tools for code checking. And currently we use Finebox, which is a Java library which scans your application and it looks for common Java mistakes, like rounding errors. And we use Lint. Lint is a great tool. It looks for common Android mistakes, like missing translations, if you have some deprecated versions of your library, and so on. And the great thing is that Jenkins has support for Finebox and Lint. And it basically looks to them as they were some tests which has to be passed. So basically we have like 100 unit tests, then we have Lint report, then we have Findbug report, and if anything fails, we immediately know that we have broken our code. And in the end, we also defined our check style, so that all the developers are using the same check style, that we have reduced the number of Git conflicts to the minimum. And okay, now we were very, very happy, but to be honest, we developers are never completely happy with our process, and then we said, okay, fuck it, let's automate all the things. And once again, we perform an analysis, and now we were unhappy with shipping the software to our clients. Because if you want, once again, make a comparison to the web development, when you deploy some code to some server and you open this web page in your browser, you immediately see the changes. But in mobile world, if you did some change, you needed to reinstall this application in your mobile phone. And with CI, we were producing like 2 or 3 or even 10 builds per day, and we needed to ship them somehow automatically to our customers. And we also pinpointed some of the features we need to have from this new automatic system. It should keep the history of all versions. It needs to have access control, and somehow it needs to notify the client when the new version is available. In the end, we implemented Infinum Labs, which basically serves as our internal Google Play or App Store. It's a web application from where our customers can download the applications which are still not ready for production. So we have access control, build history. We can also install the applications by QR code, and we maintain changelogs for each version. Each build has a unique version name. We have a Gradle task which increments the version name at each compile, and you can upload the app to this web page either by web, or you can use CIL tool, or you can use custom Android Studio plugin which we also developed. And the clients are notified about new app versions with our custom library, which is called Infinum Labs Notifier. It basically checks every time you start the application if a new version has been available, and then it notifies the user either by push messages or by in-app dialogues. And we can also say that an update is mandatory, and if the update is mandatory, the user cannot use this build anymore, he needs to update it. Okay, and so in the end, the final step was analytics, because let's face it, you need to use analytics in your projects because you need to understand your users, you need to track your application, to have some results, to have some data, to know what is basically happening with your application when it goes online. And the most important thing here is that you know that mobile analytics is not the same thing as web analytics. We have different things we need to track, different events, different actions, so those two things should never be the same. You should always divide your mobile analytics from your web analytics. Web analytics basically, mobile analytics basically is you basically need to measure 4 different things. You need to measure awareness, engagement, conversion, and crashes. And crash analytics is probably the most important thing. If you look at the awareness metrics, you need to track your number of your app downloads, number of users, sessions, and view screens. From engagement metrics, you need to track monthly active users, user segments, session length, and time spent on screen. And here is one important thing. I'm having a lot of problems with explaining to my customers and to our marketing guys about time spent on screen, because in ideal application on mobile world, time spent on screen is the shortest amount of time possible. If you take a minute and consider what mobile applications you're now using, probably you all use Twitter, and you need about 30 seconds to 1 minute to post a tweet on your Twitter timeline, and then this app goes to background and you don't use it anymore, but you use it like 5 or 10 minutes. So basically, time spent on screen should be the shortest amount of time possible, but it has to be done like multiple times per day. Then we have conversion metrics, so we need to track our app events like button clicks, external links, and so on. We have funnel drop-off rate, cohorts, and user time lifetime value, because not all the users have the same meaning and value for your application. And in the end, yeah, we have to use crash analytics. You need to use it to enhance the quality of your product. You need to track all those bugs and crashes, and you need to fix them. And with crash analytics, you also have tools which basically tells you that something is wrong with your application even before your clients are aware of it. And for analytics, we use a lot of powerful free tools. Currently, we are using in most of our tools Google Analytics because it has a really nice UI and Flurry. For Crash Analytics, we use Crash Analytics because it's free. And also in a few of my projects, I'm now currently using Facebook Insights. I don't know if you are aware of it, but Facebook is investing a large amount of cash into mobile development, and Facebook Insight is really a great tool for performing some analytics, but unfortunately for now you still have to implement integration with Facebook, so your application needs to have Facebook login in order to use Insights. And this is where we are now. So this is our complete development process. We call it the Navy SEAL development process, and we call ourselves Navy SEALs. You probably think that I'm a little bit arrogant or cocky, but today I have a full confidence in my code. I know that it has a great quality. I know it's battle tested with a gazillion of tests. And even if something breaks in production, if something crashes, I have all the mechanisms which are needed to perform some debugging even before my clients are aware of it. But we had a lot of problems, as I said before, while implementing this this process. The major part of problems was with Jenkins. You probably all know that it has a really Spartan UI, low quality plugins, and really bad documentation. When we started to implement Android on Jenkins, we were basically the pioneers of it. So if you wrote into Google how to integrate Android with Jenkins, you got really like no results. Nobody did it. We had a lot of problems with setting up the security. So basically we locked ourselves out of Jenkins a few times. And this is basically not true, because we locked ourselves out of Jenkins a few gazillion times. And yeah, we also had a few problems with searching the right concept for our tests. But yeah, we fixed all of them. So for conclusion, now we have some pros and cons of this process. So if we first look into cons, today initial project setup takes more time than like 2 years before, because you have to configure Jenkins and Git and all stuff. We also now have a steeper learning curve and onboarding curve, because our developers need to know everything about MVP and Git flow and dependency injection. Developing new features initially takes more time, because you have to write tests from them, and when you're developing your application, you need to take into account that the code has to be testable, and so you need to write everything using MVP. But on the second side, we have a lot of pros. So tests increase confidence in builds. With Git flow, we have fixed all those Git conflicts, problems, and hotfixing some production bug is possible while working on new features. With Crash Analytics, we can fix crashes even before our clients report them to us. CI ensures test running. Code check and increase developer discipline. We are now more disciplined than we were 2 years ago. And with MVP, we have easier code maintenance. And all of this results in the fact that now we have happy clients and happy developers. But this is basically a lie, because we developers are never happy. We already have some plans about what we will do about this process in the future, so what has to be changed. And yeah, that's all from me, so thank you for your time. If you have some questions.
Sure if you're the right person to ask, but do you know what are the legal requirements for tracking crashes and analytics about usage and stuff like that? Because we're close to implementing that.
Yeah, I knew that this question will happen. Yeah, so basically when you are doing with your clients, when you say that you will use some analytics or crash analytics, they will say, no, you can't use this. This is stupid, because basically you gather some anonymous data from your telephones, and here you have to be you have to know what you're doing. If you're using Crash Analytics, you are gathering only the anonymous data from a user. So you get info like device name, Android version, and only the log of your crash. But you can't send any data which you can use to track on which user did this crash occur. And the same thing is with analytics. So from legal point, if you are doing everything okay, if you are using the default settings and setup from Google Analytics and Crash Analytics, you are perfectly safe, but you will need to persuade your customers and clients to let you do this, because if you will be talking with some security guy from their side, he will say, no, this is bullshit, you can't use it. So, yeah.
What else?
Why Jenkins and not TeamCity?
Yeah. When we started to implement CI, we did a research, and at that time, only Jenkins and Travis had beta support for Android, and we decided to use Jenkins because our web team used it. But as I said before, I would never use it again, and I really hope that in future months we will migrate our CI server to something else. We are currently really looking forward to use Travis, but if you have any info which CI server could be okay with Android, please come to me later and we can have a chat.
I don't do Android.
Do it.
So do your ninjas use any other Groovy tools like Spock for testing, or maybe even for writing apps? How possible?
Currently not. Recently I wrote a blog post about Android development, and I said that our major problem is Java, because actually we don't use Java, we use Java Harmony, which is somewhere between Java 6 and Java 7. And we are in constant research about what programming language could be used instead of Java. But the problem with Groovy and Scala and Kotlin and all Java derivatives is that you don't have the necessary tools and libraries to perform whole development in these languages. So currently now we use only Groovy for Gradle configuration. We did some demo applications which were written specifically in Groovy, but unfortunately this time you still don't have all the things necessary to use Groovy as a main language.
Anyone else? Thanks.
Okay, thank you.